Okay, this is video to lesson 804, proofs with rectangles. So you already know the properties of the rectangle. Remember, with proofs, there's two types of proofs. Coordinate proofs, if we're trying to see if the certain coordinates were given form of rectangle. And then there's two column proofs, which we've already done before, using the properties of a rectangle. So let's go over coordinate proofs first. So do you guys remember when we did parallelograms, all we needed to do was the midpoint formula with the diagonals to show that they bisect each other? Well, for a rectangle, it's two steps. So the first step, it's the same thing, midpoint with formula with the diagonals. And then we have to do the distance formula with the diagonals because we want to show that the diagonals bisect each other and are congruent. So if it satisfies those two things, then it does form a rectangle. So this first example, we're going to do the midpoint formula first. Remember, when we're doing midpoint with the diagonals, it's always the first coordinate with the third, because that's what makes up a diagonal, and the second one with the last one. So I'm going to be doing midpoint for AC would be -1 plus 5 is 4 over 2, which is 2. -1 plus -4 over 2, it's -5 over 2, which would be -2.5. For BD, I'm going to do the midpoint formula. That would be 5 plus -1 over 2, it's a 2. And then -1 plus -4 over 2, it's also -2.5. So if the midpoints are the same, that means diagonals bisect each other. So we move on to the next step, which is now distance formula. So for distance, for AC, and then we're going to do BD after. So for AC, we would be plugging in 5 minus -1 squared plus -4 minus -1 squared. That would be radical. 6 squared is 36. And then we have -3 squared, which is 9. So that's radical 45. No need to simplify because we're just going to see if they're equal or not. For BD, we would then have -1 minus 5 squared plus -4 minus -1 squared. So that would be, again, -6 squared is 36. And then 9, so that's a 45. They have the same distance, so yes, it's a rectangle. So remember, your conclusion here would be rectangle because diagonals bisect each other and are congruent. Now, if you do midpoint and it doesn't have the same midpoint, then you don't need to do step 2 distance because they don't even bisect each other. So it's not even a rectangle from step 1. If they have the same midpoint, you move on to distance. But if they don't have the same distance, then you would say it's not a rectangle because the diagonals are not congruent. But since they did have the same midpoint, then that tells us it's definitely a parallelogram, just not a rectangle specifically. So again, these are the two steps, midpoint and then distance. For 2 column proofs, again, we're going to be using properties of the rectangle to prove what they want us to prove. So again, here are the properties: opposite sides congruent, opposite sides parallel, opposite angles congruent, they all equal 90, consecutive angles are supplementary, diagonals bisect each other, and diagonals are congruent. So using those properties and having those in mind, we're going to prove here example 1. Given a rectangle ABCD and AE is congruent to CF. So they already gave us that side. And we know this whole thing is a rectangle ABCD and AE is congruent to CF given. So here we want to prove that this triangle ABE is congruent with this triangle over here, CDF. So we know this is a rectangle, so I can say AB is congruent to CD. AB congruent to CD. Why? Opposite sides are congruent in rectangle. Now, in a rectangle, we also know that all angles equal 90 degrees. So that means I'm gonna have to use angle B with angle D. They're both equal to 90. So that's what I'm gonna say next. Angle B is congruent to angle D. Why? In rectangle, all angles equal 90 degrees. And now look at your triangles there. What method does that look like? Oops, this should say 3. It's HL. So now remember, before using HL, since they didn't tell us these were right triangles, we have to say that step 4, triangle ABE and triangle CDF are right triangles. You can say triangles have right angles. And then I don't think I could, I could erase this so that I have more space. No, I can't. Okay. And then step 5, sorry for the space here. Now we can say triangle ABE is congruent to triangle CDF, whoops, F, by HL. Okay, so again, you're using the properties of the rectangle as your reasons to say to back up the statement you said about the triangles. Okay, so now you can move on to assignment 804 on your Google Classroom.